Hi folks, this is Math and Physics for you. Today we're going to talk about vector fields. This concept is encountered in nature in so many situations, especially in engineering areas, such as the force of attraction between planets. Also, electric fields, magnetic fields, velocities uh, when fluids flow in pipes, etc. Now we will use the example of the force of attraction between planets or two objects. As you know from Newton's law for universal gravitational attraction, F, which is the magnitude of the force of attraction between any two objects at a distance r from each other, is given by this formula. F, the magnitude, that's why we put the absolute value, G, gravitational constant of attraction, M, the mass of the first object, capital M, the mass of the second object. So as you can see, this is not a vector. This is a scalar function. This is a scalar function because it has no direction. And as you can see, as R increases, this force will decrease. Now we want also to know the direction of this force because the magnitude itself is not good enough. So to obtain the direction of the force, which is a vector now, we multiply this scalar quantity by the unit vector in the direction of R. And that unit vector is simply found by dividing R by the size of the unit of the vector, that is the distance between the two objects. So it is given by minus R, the vector, over R, its length. Minus, we use it, the negative, as the direction is towards the, let us say, towards the Earth, towards this object. Now, if we plug this formula for the unit vector here, it gives us the force vector. So F equals GMM over R squared multiplied by R, the vector, over its magnitude with negative. So that becomes GMM over R cubed, R, the vector direction. Again, what's more useful for us if the expression is in terms of x, y, z, because x, y, z are the coordinates of any point in space. If we want to find the magnitude of the force at any point, x, y, z. So R as a vector is given by its components, xi plus yj plus zk, and its length is simply the square root of x squared plus y squared plus z squared, written as this to the power half. Now putting it back in this formula, replacing R cubed with that, we get what we see here, 1 GMM x over square root x squared plus y squared plus z squared cube I, and so on. Could be written simplified as this denominator. Instead of this one, we can write it as x squared plus y squared plus z squared to the power 3 over 2. So this is an expression for the force vector, for the force of attraction between the two objects at any point x, y, z in space. And if we plot it using a computer program, it's going to show you so many vectors with their sizes and direction similar to what we see here. In this case, will be directed towards the object. So this is a simple example of a vector field. As we said before, that this the same concept is applied to other areas. And in general, we can write the equation for any vector field as like F equals a function in terms of x, y, z multiplied by I, another function in terms of x, y, z times j plus another function x, y, z, k. That gives the vector field. So there you have it, folks. Next time we'll talk about the conservative of vector functions. Thank you and see you. Please subscribe.